Okay, guys, we're going to take a little slight wrap up here and we're going to look at circumference and arc length. So, this is going to be that outer edge. We're not talking about filling in anything this time like we did with area. So, now we're just looking at circumference, the measure of the outer edge of the circle, or arc length, which is just a part of that circle. So, we looked at sectors, which is a part of the circle with area. And now we're going to look at arc length, which is part of the circle on the outer edge. So if you'll remember back, that circumference, so this, I say back, not this year, I'm talking maybe seventh grade is probably when you last saw it, that the circumference of a circle is going to be 2 times pi times radius. Or you can also write that as pi times diameter, since the radius could be multiplied by 2, and that's how you get the diameter. So you could do either one. So that's for the circumference. So take what you're given. So with area, you have to have the radius. But with circumference, it's really nice because you don't always have to have the radius in order to be able to find the circumference. You can use it straight from the diameter. Now let's talk about arc length. So arc length is the exact same whenever you are looking at the sector and the arc length, except we're not talking about the area piece. We're going to be talking about the outer edge piece. So the arc AB, to find that length, it's going to be theta over 360 times the circumference, so 2 pi r. Here, you probably won't use diameter because the arcs are made up of the radius. So the radius would have to be given to you and labeled for you there. So just a quick label here. Remember, radius goes from the center of the circle, and then diameter goes all the way across. Okay, so let's look here at our first one. It says find the circumference for a circle with a radius of 18 centimeters. So I can just plug this straight into the 2 pi r formula. So the circumference is going to be 2 times pi times 18. And then multiplying all of that together, I'm going to get 113. And it was 0.097, but that 7 makes that 9 round up. And if I'm going to round to the nearest hundredth, it's going to be 0.10. So go ahead and write that, not just 0.1, but 0.10, showing that you rounded to the nearest hundredth. And this is just centimeters. So with area, it was square centimeters that would cover what we're talking about. This time it's just centimeters because we could use like a string and measure it around a circle and then measure that, stretch it all the way out, and that would measure out to be roughly this. So this is again an approximation because we have to use pi. All right, so now on the second example, it gives us the circumference this time, and we're trying to find the diameter. So on this one, I'm going to use pi times diameter. I'm not going to use the radius one and then multiply by 2 at the end when I have a formula that has the diameter in it. So the circumference is 21 is equal to pi times the diameter, which we don't know. Remember that pi is a number. I know we don't normally always write it as that, but it's still a number. So I'm going to divide by pi on each side. So I get 21 divided by pi. So that's roughly going to be 6.68 is going to be the diameter. If I was asked to find the radius, I would use the radius formula and still do the exact same thing. I was actually divide by 2 pi. You can divide by that because that's going to give you an actual number. So don't treat pi like a variable, like for here, like diameter that we use with d. So pi is not a variable. We just use it as a symbol to represent a number that we can't write because there's not an end to the decimal. Okay, so this one says, what is the length of arc MN? So I'm going to go from M to N. So this is how you write that. MN, the little arc above it, is going to be equal to 85. Actually, you know what? I'm going to go ahead and write out the whole formula because I think it's a good thing to do. So theta divided by 360 times 2 pi r. So arc MN is going to be 85 divided by 360 times 2 pi, and my radius here is 12 right here. So this is going to all multiply out to be 17.80, and this is centimeters because this is in centimeters. And this is just the outer edge of a circle and just not even the full circle. So I just measure just a part around it. And then I would I would take that string and I could use my ruler and stretch it out. And I would measure out to be 17.80. All right, on question number 4, I'm going to have to add in a radius. The radius is going to be 10. I'm going to use inches this time. We're trying to find the measure of PQR. So you've got to go in this order right here. So arc PQR is going to be equal to theta divided by 360 times 2 pi r. Now, I don't know what theta is because I have 145 on the bottom, but I don't know this one. This is my theta, really. So I can take 360 minus 145, and I'm going to get 215. So that's my theta, 215. Okay, so remember, an entire circle is 360, so I had to use that to be able to find this. So this arc PQR is going to be 215 this time, divided by 360 times 2 times pi times 10, which is our radius that we added in. So then multiplying all of that out, I'm going to get 37.52, and this is going to just be in inches. So that's going to be PQR. So you might have to find, so just be careful about that because you don't want to use 145 here because that's the other piece of it. So you would take that, subtract it from 360, find that what's resulting. So there was some of like that was in your sector piece there, sector lesson, but and then just go from there, use that as theta. So we've talked about circumference. This is the outer edge of a circle. Then we talked about the arc length, which is just that part of it. So that's still going to be that inner angle, that theta, that central angle, divided by 360 times the circumference, because you're just talking about part of that circumference there. And so that's it. And it is now your turn to practice with your skill check.